Hello friends! Welcome to Electrical Design Engineering YouTube channel. You can watch my videos in your language. Follow the steps to set your language. Step 1. Click the gear icon. Step 2. Select audio track. Step 3. Select your language. You may contact me for industrial design substation layout power system studies on +9 1700 647 4688 call or WhatsApp.
This is lecture number 7 of our free course DIgSILENT PowerFactory. In this lecture we will study about the tap changer of a transformer. So what is the tap changer and why it is placed, and that means one more thing we will see manually. We will calculate the manually tap setting, which tap setting is calculation in which tap setting, and the voltage is 1 per unit, what will be the tap setting when the voltage is below 1 per unit, what will be the tap setting, and when voltage is above 1 per unit, what will be the tap setting. Then we will also see through the DIgSILENT PowerFactory. You know that the electrical power system experiences continuous voltage variations due to load changes, long transmission distance, faults, and system disturbances. To maintain a stable and acceptable voltage at consumer terminals, transformers are equipped with a tap changer, a mechanism that allows adjustment of the voltage by changing the transformer turns ratio. So we define a tap changer is a device or a mechanism connected to a transformer winding that maintains the output voltage within the acceptable limits by changing the turns in predetermined steps. We know that the ratio of the high voltage to the low voltage is equal to turns on the high voltage side divided by the turns on the low voltage side. From here you can see the low voltage side is equal to turns on low voltage side divided by turns on high voltage side into VH, that is the voltage on a high voltage side. For low voltage is inversely proportional to the turns on HV side. From here, this equation you can see the low voltage is inversely proportional to the number of turns on the high voltage side. So increasing the high voltage turns lowers the LV voltage decreases, and decreasing high voltage turns results in increasing the low voltage. What is the tap changer installed? HV winding or on LV winding? The tap changer is generally placed on HV winding because of the below reasons. Low current on HV side. On HV side, the voltage is high and current is low. Low current leads less arcing and heating effect. More number of taps available. On HV side, the number of turns are more as compared to the LV side, so more taps are available for the fine voltage control. Easy to take taps from the HV winding. In the core of the transformer, the LV winding is placed on the HV winding. You can see from this figure, this is the LV winding and this is the HV winding. So it is easy to take the taps from the HV winding because the LV winding is below the HV winding. Types of the tap changers. There are two types of tap changers. One is off-circuit tap changer, or it is also called off-load tap changer, and another is on-load tap changer. Off-circuit tap changer, in this case the transformer must be energized to change taps. It is simple, inexpensive, reliable, and generally used in distribution transformers. In distribution transformers you have seen this type of a wheel. This is a offload tap changer. In the offload tap changer you have to connect the transformer from the supply and then change the taps manually. On-load tap changer. In this case the transformer remains energized and under load while changing the taps. That means the transformer is not disconnected from the supply, but we are changing the taps while the transformer is on load. It is automatically or remotely controlled. It is used in transmission, grid, and industrial systems. OLTC transformers may include an AVR controller that continuously monitors LV or a bus voltage, compares with the reference voltage, changes steps automatically to maintain the voltage within the acceptable limits. This is the on-load tap changer, and this is the control box, and this is like the mechanism how it is connected in the transformer. Standards governing tap changers. The standards governing the tap changers are IEC 60214-1. It covers its design, construction, testing, performance and safety, and operation, duty and installation. And IEC 60076, which is a transformer standard series, specifies transformer requirement including tap changers and ratings, and IEC 6007761-1 defines the typical tap arrangements. Now we will see, this is the nameplate of a distribution transformer. Here you can see the tap tap changer setting is given that HV 11 kV plus minus 2 to 2.5. That means each step is changing the turns by 2.5%, and the maximum is 2 is above and 2 is below. That is 1, 2, 3, 4. Total is 5 steps. The maximum voltage turns changes 5%, plus 5% to minus 5%. Each step changes HV turns by 2.5%. So the effective HV ratio becomes, so you can see the VLV per unit is H per unit into 1 plus 0.025 into T. T is the tap position at 1 or 2. Case, we will consider the case first when the HV voltage is 1 per unit. LV becomes when T is 0. Here T is, we had put in the tap setting at 0 position. The 0 position here is 3. That means we do not change the tap setting. We are using, we are not changing the tapping by putting at 0. That means LV will be 1 per unit. And now case set when the HV voltage is 1.05 per unit. In this case we have to decrease the number of turns. So we can first check at minus 1 it becomes 1.02, at minus 2 tap setting it becomes 0. LV voltage becomes 0.99 per unit, that is around 1 per unit. Our target is that the LV voltage should be 1 per unit, so the tap setting will be at minus 2. Case third is that when HV voltage is 0.95, LV voltage, so 0.9 we have to increase those. That means the tap setting will be positive. So at 1 tap setting 1, that is this position, our voltages on LV side will become 0.97, but at this position, that is on second position tap setting, that it becomes 0.99. so our tap setting is 2 because LV voltage is almost 1 per unit. Now you have seen these things, how the tap calculation is going on in the transformer. This is the manual calculation. Now we will see in the DIgSILENT PowerFactory.